Today's video will continue our discussion of what it takes for triangles to be congruent. We'll be using IC19 as our notes for today. If you'd like to find that and follow along, that may be helpful. So what's different about today than what we've talked about previously is that in order to identify one of our 5 triangle shortcuts, we may need to also use some additional information, which might have shown up in previous standards or might be new for this standard. And what that additional information will tell us about will be either congruent side pairs or congruent angle pairs, depending on what the information is. So as you'll notice, some of these are review. The definition of midpoint is something that we've been using since standard 1. So if we think about what it means for A to be the midpoint of segment CE, that would focus in on this particular portion of this diagram, since they talked about point A and segment CE, and we would be able to mark that these two segments are congruent as a result. So we would have segment CA congruent to segment EA, which would be in these triangles an additional pair of sides that we wouldn't know about without that particular piece of given information. The next one is also review. The definition of angle bisector is something that we studied in standard 2. So if segment GI bisects angle FGH, that means that it divides that angle into 2 congruent parts. And so we would be able to name the top angle, angle FGI, and we would be able to say that that angle is the same size and shape or is congruent to angle HGI. So that time around, the definition of angle bisector would provide us with an extra set of congruent angles that we could use if we were dealing with these 2 triangles. The next one is also review from standard 2. Vertical angles theorem showed up anytime we had an X shape and we were concerned about those angles that were across from each other in the X. So for this diagram, angle BAC would name the one that's on the left side of the picture, and angle EAD would name the one on the right side. And again, that would be an extra pair of congruent angles, thanks to vertical angles theorem. The definition of isosceles triangle is something we learned about in standard 3. We never wrote down our reasons for standard 3, but we definitely learned about what the word isosceles meant. We knew that when a triangle was isosceles, it had 2 congruent sides. And so what we have to be careful of when we're dealing with proofs is that we understand which sides those are. That's why they've given us this clue about the base. So if the base is segment UV, that is actually the side of the triangle that is not congruent to the others. So if we're investigating triangle TUV, TU would be one of the other sides, and TV would be one of the other sides. So those are the 2 that would get the congruent marks. We'd be able to say segment TU is congruent to segment TV, thanks to the definition of isosceles triangle, and those are sides of that triangle. The base angles theorem is also from standard 3. The base angles theorem was what we did when we had congruent sides present, and we ended up traveling across the shape to the opposite angle. So we're going to ignore this segment in the middle and just think about this isosceles triangle, this outside boundary, and we're going to travel to the opposite angle from this congruent side and the opposite angle from that congruent side. So we end up with angle P and angle Q as being the 2 angles that have equal measure, or now are congruent, thanks to our base angles theorem. So that gives us more congruent angles to use in our congruent triangle situations. Moving on to the next one, the right angles theorem is next. This is a new one, so is the bottom one, the reflexive property. The right angles theorem talks about what happens if we have a right angle in both of our triangles. The definition of a right angle would tell us that each of these angles measure exactly 90 degrees, but if they're both 90 degrees, we would be able to say that their measures are equal to each other, because 90 degrees equals 90 degrees. And anytime we're able to say measurements are equal, we can change that into a congruent statement by dropping the M and changing that equal sign into a congruent symbol. So angle Z will be congruent to angle G because they're both right angles. So right angles theorem will be a new way for us to get additional angle pairs that are congruent. And then our last new option is going to be called the reflexive property. The reflexive property happens when things are shared by both triangles in the picture. So most of the time, it will end up looking like this diagram right here, where if we focus in on segment CD ends up being a side for triangle CDB, but it's also a side for triangle CDE. And so even though it's only one segment, since it would be the same size as itself, I know that seems weird, but things are the same size and shape as themselves, we can say that segment CD is congruent to segment CD itself, and that counts then as a set of, a set of sides, because that side is used in both triangles. Now, I'm not going to get rid of the fact that I circled angles because reflexive property can actually be used for angles as well. That would happen in a picture like this one. So this is not quite as common, but it is possible. I'm going to focus on triangle FHI, so that orange triangle, and I'm going to try to pick a color that will make this one look different. Triangle GJH. Okay? So when I outline that, I'm not sure if you can tell because the colors kind of bleed together, but down here in this corner, that angle H was orange because of my first triangle, but it was also purple because of my second triangle. And so if that angle, again, is used in both triangles, it's shared, and it represents one of the three angles in each triangle, we can say that that angle H is congruent to itself, and then that gives us a pair of congruent angles that we could also use as we're looking for different side, side angle, side, or any of the others that we've studied so far. So a lot of this information, 5 out of the 7, are review from standards 1, 2, and 3, and then these two, right angles theorem and reflexive property, are the two new ideas that you'll need to know now that we're in standard 5.